Right, in this video, we're going to look at radical expressions and radical equations. This is an example of a radical equation. We're going to solve for the letter x. Now, the goal is to get x by itself, but we realize x is caught inside the radical. So we're going to have to square the radical to get rid of the radical expression. So when you see something like radical 2x and you square it, it becomes 2x. Okay? So in the same sense, that's what we're going to do. But before we do that, we want to rearrange the equation to make it easier. We're going to move the negative x to the other side so that you'll end up getting 2x plus 7 equals 2 plus x. Now you have to keep this in mind. When you do something to one side of the equation, you have to do it to the other side as a whole. So on the left side, we're going to square it. On the right side, you must not square it individually like this. Okay, that's actually wrong. What you want to do is square it as a parenthesis like that. Okay. This radical will simply come off when you square it. So this will be 2x plus 7. And here you have to make sure you distribute it out like this. Now, some students make the mistake of doing something like 4 plus x squared. This is actually wrong, okay? When a parenthesis is squared, the whole parentheses is being doubled or multiplied by itself again. So that's why you have parenthesis times parenthesis, and you have to distribute each of them out. So this will become 4. 2 times 2 will equal 4. 2 times x will be 2x. In the middle 2 will become 2x, and the last 2 will become x squared. Just do some simplifying. Those 2 will become 4x. So you got 4 plus 4x plus x squared. And now you need to solve for the letter x. Now, the moment you see an x squared, it becomes a quadratic situation. To solve for a quadratic, two main methods, set it equal to 0 and factor it, or set it equal to 0 and use the quadratic formula. Since x squared is positive, I'm just going to move both of these to the other side. So this will become 0 equals, let's see, 4 minus 7 is negative 3. 4x minus 2x is 2x and x squared. And now let me rearrange this in decreasing order. X squared plus 2x minus 3. And you should be able to see that it factors out. How do we know that? Two numbers that multiply to negative 3 are 3 and 1. And 3 and 1 can add up to or subtract down to 2. So we're going to go like this and put x's right here because x times x is x squared. Negative 3, two numbers, again, 1 and 3. But to add those up to become a 2, then 1 needs to be a negative. And so I'm going to plug that in right here. X minus 1, x plus 3. Now, when I do this, I do a quick double check because sometimes you can actually make a mistake. So you check it out. X and x becomes x squared. Negative 1 and positive 3 becomes negative 3. To check the middle term, you do the outside 2 multiplied and add the middle 2 multiplied. So 3x minus x is 2x. So here x is equal to 1 and x is equal to negative 3. You're not done. You always, okay, whenever you square both sides of an equation, you must always double check your answer, especially with regards to radicals. So plug each one of them in. If you plug 1 into our equation, you'll get 2 times 1 plus 7 minus 1 equals 2. That's basically 9 minus 1 equals 2. So 3 minus 1 equals 2. 2 equals 2. So check. X equals 1 does work. Okay. And then the next term, we're going to try negative 3. And so square root of 2 times negative 3 plus 7 minus negative 3 equals 2. So we get 1. 3, I'm sorry, that's negative 6 plus 7, which becomes 1. And notice something plus 3 will always be bigger than 3, so it's not going to equal 2. Okay, or square root of 1 plus 3. 1 plus 3 equals 4. 4 does not equal 2. So here we're not going to choose x equals negative 3. This is what you call an extraneous. Okay, extraneous. It just means you get an extra answer that doesn't actually work. So this is our actual answer. Now you might be asking, well, why do we get extraneous answers when we're doing the math correctly? Well, it's because whenever you square both sides of an equation, there's a mystery with regards to what that original number was. Let me show an example. For example, if you have like negative 5 and 5, and you square both of them, you get 25. But notice, if I erase the terms inside here, what squared equals 25? Well, it could have been one or the other. We wouldn't know. There's a mystery. You understand? Did I just put 52? Yeah. So 25. Okay, so just because the answer or the product of the result of the squares are positive 25, we don't know if it was a negative 5 versus a positive what? 5. And that's what happens when you square both sides of an equation. This could have been a negative or positive. By squaring it, you're turning it into a positive result. You work it all out, and then you have to go back and ask yourself which one of these two it was originally. Okay, so that's why you have to go back and plug it in. All right, now here's a situation where you have two radicals. Now you might think, well, let's just jump in and square both sides right now. You can, it'll just take a little bit longer, actually much longer. So what you want to do is keep a radical on one side and move the other radical to the other side. And you're going to inevitably square it twice. Let me show you what I mean by that. So you have 2x squared, radical 2x minus 5 equals 1 plus square root of x minus 3. And then from here, you're going to square. Again, on the right side, square the whole thing, and you have to distribute this. The left side will become 2x. Let me keep my colors consistent. All right, so on the left side, you have that times that. So you have 1 plus radical x minus 3, 1 plus square root of x minus 3. And if you multiply this out, 1 times 1 becomes 1. 1 times radical x minus 3 becomes plus radical x minus 3 plus radical x minus 3 plus, and radical x minus 3 times radical x minus 3 just becomes just x minus 3. Okay, now these two in the middle, you can combine these two. They're like terms. So this will become 1 plus 2 square root of x minus 3 plus x minus 3. We can combine the 3, the negative 3 and the positive 1. They'll become negative 2. We'll bring the x to the front using the commutative property of addition. And then this will become 2 radical x minus 3. And what you can do is now move these to the other side. So 2x minus x will become x. Negative 5 plus 2 will become negative 3. And you're left with 2 square root of x minus 3. And you notice you have to do it one more time to get rid of this radical and bring that x out. So you square both sides again, x minus 3 squared, 2 square root of x minus 3 squared. And just be careful when you do these. This is going to become x squared minus 6x plus 9. And this, when you square the 2, it becomes 4. And when you square the square root, you get x minus 3. And again, you have a quadratic situation. You have an x squared, set it equal to 0. So you'll end up getting x squared minus 6x minus 4x plus 9 plus 12. Now you might be asking, what did I do? Well, I just like added numbers. I did this in my head. This will become 4x minus 12, and I subtracted 4x to negative 6x. You get this, and then the 9, and then the plus 12 becomes, the negative 12 here comes on this side to become plus 12. So now you have x squared minus 10x plus, and that's 21, equals 0. And immediately in my mind, 7 times 3 equals 21, where 7 and 3 becomes negative 10 if both were negative. If both are negative, negative 7 and negative 3 becomes positive 21. So x minus 7, x minus 3 equals 0. Does that make sense? X and x becomes x squared. Negative 7, negative 3 becomes positive 21. Outside numbers, inside numbers become negative what? Negative 10. So x is equal to 7 and positive 3. Again, you always double check. So let's zoom out. Let's go back to our original equation. And let's plug in x equals 7. And so you get square root of 2 times 7 minus 5 minus square root of 7 minus 3 equals 1. 14 minus 5, what is that? 14 minus 5 is 9. minus, and then this will become 4. This is 3 minus 2 equals 1. 1 equals 1. Check. All right, 7 works. And what about 3? So x is equal to 3. Let's check that. So that becomes, I'm just going to do this in my head. 3 times 2 is 6. 6 minus 5 is 1. And then 3 minus 3 is 0. So we get that. Aha! So both of these work. 1 equals 1. Check. So your answer is x equals 7 and what? And 3. I think there's one more that I wanted to do. This one. Now this one, I know the solution is going to be, well, the solution is no solution. And you'll see why. After we figure this out, when you plug it back in, it's not actually going to work. So again, we're going to do what we did before, move one of the radicals to the other side. And I'm going to pick up the pace and do more in my head. So you square both sides, you get 2x plus 3. And then you square both of those. Here, I just put that there. You get 4. And then you get negative 4 square root of x minus 2 plus parenthesis x minus 2. And then you, let's see, 4 minus 2 will become 2 plus x minus 4, negative 2, 2x plus 3. And then you bring the 2 to the other side, you'll get a 1. 2x minus x, you get an x, you get x plus 1, negative 4, okay, and then you do it again, squared, squared, and this will become x squared plus 2x plus 1 equals 16 parenthesis x minus 2, okay? All right, so this will become 16x minus 32, x squared plus 2x plus 1, and I know I'm going kind of fast, but you shouldn't, you know, if you can just do it on your paper, you can follow, or just put into that half speed kind of thing. X squared plus 2x. Okay, so you got x squared, 2x minus 16x is negative 14x. 1 plus 32, you get 33. And immediately what comes to your mind is 11 times 3, because 11 plus 3 is 14. Wow, ha, ha. All right, so you get x minus 11, x minus 3. Negative 11 minus 3 is negative 14. Negative 11 times negative 3 is positive what? 33. So you get x equals 11 and 3. And it just seems like everything's working out until you actually plug it back in and it doesn't work. So let's try it. X equals 11. So if you plug that in, you get, let's see, 11 times 2 is 22. 22 plus 3 is square root of 24, which is not a perfect square, plus 11 minus 2 is 9, so square root of 9, and it's got to equal 2, and you realize it's not going to work. Square root of 24 plus 3 is never equal to 2, so x equals 11 does not work. And then the next one, 3. So if you plug in 3, 3 times 2 is 6, 6 plus 3 is 9, so you get square root of 9. You plug in 3 right here, 3 minus 2 is 1, square root of 1 is just 1. And does that ever equal 2? You get 3 plus 1 equals 2, you get 4 does not equal 2, so what is this one? X equals 3. None of these works, so no solution. Okay, well, I hope that helps. I hope you'll get an A next time.